Now, real numbers and their decimal expansions. Real number means rational and irrational number both. In this section, we are going to study rational and irrational numbers from a different point of view. Earlier, what we discussed? That rational numbers are those numbers which can be expressed in the form of P by Q, and irrational numbers are those numbers which cannot be expressed in the form of P by Q. Now here, as I'm telling you, as I've told you earlier, that from a different point of view, we are going to study about real numbers. Now first of all, let us see the decimal expansion of 7 by 8. Now 7 by 8, decimal expansion of 7 by 8 is equal to 0.875. Actually, we have to divide it by division method properly and then find out the quotient here. Quotient is 0.875. This is the case 1 in which the remainder becomes 0. And this type of decimal expansion is known as terminating decimal expansion. Terminating means it terminates. There is no number after this. 7 by 8 is equal to 0.875. Now similarly, 10 by 3. When we divide 10 by 3, डेसिमल एक्सपेंशन यानी कि कोशेंट जो जा रहा है आपके पास यहाँ पे वो आ रहा है 3.33 एंड सो ऑन. 10 by 3 is equal to 3.333 and so on. The number which is repeating again and again but not terminating is represented by bar. जो number repeat कर रहा है, it may be a 1 digit number, it may be a 2 digit number और so on. आप उतने ही नंबर के ऊपर वहाँ पर बार लगाएंगे. अगर दो नंबर रिपीट हो रहे हैं, फॉर एग्जांपल जैसे कि आपके पास कोई नंबर है जो बार बार रिपीट हो रहा है 4141 सो ऑन, दिस मे बी रिटन एज 0.41 बार. तो 10 by 3 is equal to 3.33 and so on. So 3.3 bar. 3 bar means this 3 is repeating. This is the second case. The remainder never becomes 0. Never becomes 0. Therefore, decimal expansion is non-terminating recurring. Recurring means repeating. Non-terminating repeating decimal expansion is there, as we discussed in the case of 10 by 3. So when we, in case of rational numbers, when we divide numerator by the denominator, there will be two types of cases. Case 1, the remainder becomes 0. Case 2, the remainder never becomes 0. There will be two cases. So more example. Let us see more examples. Case 1, 1 by 2 is equal to 0.5. 23 by 100 is equal to 0.23. Similarly, case 2, 1 upon 999 is equal to the number, this number is a non-terminating recurring number, that means 0.001. These three digits are repeating again and again. The bar is on these three numbers as I written here. 0.001, 001, 001 and so on. It means these three digits are repeating again and again. So that's why we have this written bar on these numbers. It means the decimal expansion of our rational numbers is either terminating or non-terminating recurring. So in these rational numbers, in all the rational numbers, there will be two types of decimal expansion. One is decimal expansion is terminating, other is decimal expansion is non-terminating recurring. It means a number whose decimal expansion is terminating or non-terminating recurring is rational. So here we have introduced one more definition of rational number. Earlier what we discussed? We discussed in the form of P by Q. Now here in this lecture I am discussing here the one more definition of rational number, that is a number whose decimal expansion is terminating or non-terminating recurring is known as rational number. Now next is the decimal expansion of an irrational number is non-terminating, non-recurring. It is the opposite of rational number. In irrational numbers, decimal expansion is non-terminating, non-recurring. Non-recurring means non-repeating. It means a number whose decimal expansion is non-terminating, non-recurring is irrational number. So again, we have discussed one more definition of irrational number in the form of decimal expansion, that a number whose decimal expansion is non-terminating, non-recurring is known as irrational number. For example, when you try to find out root 2, value of root 2, the value will be, as you can see, the numbers are not repeating. Digits are not repeating, and it will continue till we divide. We will find out more numbers. Similarly, pi is equal to 3.14 and so on. And both the decimal expansions are non-terminating, non-recurring. Both here we have discussed root 2 and pi here. Note that we often take pi by 22 by 7, that is pi 22 by 7 as an approximate value for pi. We have discussed earlier in your classes here in 8th standard or 7th standard, when we discuss the value for pi, we generally say that pi is equal to 22 by 7. That is, you should understand that approximate pi is equal to 22 by 7 we are using as a pi, because 22 by 7 is just an approximate value for pi, but pi will not be equal to 22 by 7. Now, this is all about our